In a world where space and time are intertwined, one man dared to challenge the status quo. His name? Dayton Miller. His weapon of choice, a flute. But not just any flute. This instrument held the power to unleash the ether, a pervasive medium once thought to fill the universe. Miller, a physicist by trade, a musician at heart, discovered a harmonic resonance within the ether. He found that his flute, when played with precision, could manipulate this elusive medium. His melodies, a symphony of science, had the potential to shift.
All right, hello and welcome to Aether Roundtable number 63. Tonight, Dr. Michael Heffron is joining us to give us some tips on debate tactics. I think he's going to go over some different scenarios and how to do logical argumentation without being fallacious. Take it away whenever you're ready, sir.
Okay, first of all, I'd like to thank Cass and Eric for their suggestions on how to improve this presentation. And then I'll also apologize for any mistakes that might remain, maybe on things I didn't do right or that I added later and they didn't get a chance to re-review. It's challenging for all of us to break free from the indoctrination of false information. So I understand why Mike of Conspiracy Tunes believes what he does. I was surprised to hear McToon's relativistic nonsense about the goal and results of Airy's 1871 experiment that Alan presented at last week's roundtable. And then, and also I was very, very impressed by how calm and respectful Pizzo was during that discussion. I think he was a role model for all of us. It was McToon's relativistic mysticism that inspired this presentation. And this is my attempt. And I've always been skeptical of relativism anyway, but when I heard him present it, it just sounded like utter nonsense. So I'm going to attempt to be minimally tutorial while I'm discussing how we can acquire knowledge and wisdom despite misdirection, widespread lies, our own skepticism, and many gaps in our knowledge. And this material is applicable to debates. And if anybody wants to do a dissertation, it's also applicable to doctoral dissertations. And of particular interest, I think, is how to minimize non-productive discussions. At any time, yeah, that's challenging at times because they want to keep throwing up straw men. They want to throw in red herrings. They want to use every debate tactic that anybody who's ever taken debate studied in school, just to get us off track. And so this is about getting back on track. At any time during this presentation, please ask me to go back or clarify anything that seems unclear or confusing. And also feel free to interrupt at any time with questions.
Yes, sir.
All right. Just over a century ago, William Seeley Gossett, something he called small sample hypothesis testing. And his form of modern hypothesis testing recognizes that a hypothesis can't be proven to be correct. So rather than arguing the validity of a hypothesis, Gossett advocated demonstrating the falsity of its opposite, which he called a null hypothesis. And I'm using a noise canceling microphone, but if you hear a dog barking in the background, I apologize. That's my 15-month-old puppy.
No worries. You're sounding great.
Oh, good. So the noise canceling is actually working. I'm glad. The null hypothesis testing is what many major universities require their doctoral students to do. And the advantage of that form of modern hypothesis testing is that there is absolutely no need to validate any assumptions or hunches. And the reason for that is any invalid assumptions will cause the null hypothesis to be true, which means the hypothesis is incorrect. And that's the condition shown in the blue text on this diagram. Another advantage of this form of hypothesis testing is that doctoral students especially can just swap the hypotheses to redeem their doctorate if their original hypothesis was wrong. And then the green text at the intersection of false and rejected represents the goal of rejecting a false hypothesis. And when you reject the false hypothesis, then you have some level of confidence that the hypothesis is probably not wrong. And some examples of rejecting the null hypothesis and how confident you can be in that are coming up soon. So first, if you've never seen this device, I wanted to show you this. In the late 1800s, Sir Francis Galton invented what he called a bean machine, and later people started calling that the Galton board. In this modern version, tiny steel balls bounce off the pegs in random order so that nobody can know what path they will take, and yet we can know the balls will ultimately form a bell curve. And that indicates what is called by statisticians a normal distribution of the random probabilities. This normal distribution of random events is an example of something we can know about the things we don't know. And I want to take a little interlude. To become wise, there are some things we have to learn. We have to learn there are things we do not know. There are flaws in what we think we know. And we must learn where truth lies. And where truth lies has a double meaning. And finally, we must learn that God uses simple things to confound the wise. Some prefer to call that Occam's razor. Now, here's where we'll start to get interesting. Many researchers believe the Earth and other planets are not actually spheres, but instead are slightly oblate, and they say that's due to the combined effects of gravity and rotation. So let that sink in. There is really no debate about whether the Earth is flat or round. The debate is really about how flat or how round. This presentation is going to discuss topics such as subatomic particles and ellipsoids, and I'm doing that to promote clarity, not to endorse the validity of any of those concepts. And probably everybody here knows all of those concepts are debatable. But for the sake of this discussion, let's assume for a moment that subatomic particles actually exist as ellipsoidal whirls of ether. And that's Nikola Tesla claimed that mass was just whirling ether. So ellipsoids may be spherical, oblate, prolate, or egg-shaped things. And this presentation is going to use the section symbol to represent the 4 pi over 3 scalar that converts the product of the axes to the volume of an ellipsoid. The important thing to understand about that is that the volume of an ellipsoid does not depend on knowing its shape. And also during this presentation, it's important to understand that anytime I refer to a radius, that refers equally well to a semi-major axis of any ellipsoid. Let's now examine what was wrong with the Michelson-Morley hypothesis. They claimed they were looking for luminiferous ether, but what they were really looking for was evidence that the Earth was traveling 30 kilometers per second through stationary ether. Michelson knew how to build an ingenious interferometer, and when they used that to test the ether, they didn't detect the motion they were expecting. And they did consider other alternatives, but they failed to consider that the Earth might not be moving, or that it might not be moving as fast as they thought, or that the ether might be moving with the Earth. And as a result, many people foolishly concluded that luminiferous ether didn't exist. In their defense, all of their craziness occurred 2 decades before Gossett proposed small sample hypothesis testing. Only a mathematician could love the probability and statistics required to reject the null hypothesis. And I'm going to leave the complexities of hypothesis testing for independent research by anyone who is interested. But this is an overview of the most important concepts. This bell curve, they call this thing a bell curve. It illustrates what is called standard deviations, and those are denoted by the Greek letter sigma within the shaded rectangles. And those are deviations from midpoint, and that's denoted by the Greek letter mu under the red center line. A standard deviation of plus or minus 1 sigma produces a 68% probability of rejecting a false null hypothesis. Similarly, a standard deviation of plus or minus 2 sigma produces a 95% probability of rejecting a false null hypothesis. And a standard deviation of plus or minus 3 sigma produces a 99% probability of rejecting a false null hypothesis. And you can read the other percentages next to each of the other sigmas. The requirement for many doctoral dissertation is just to reject the null hypothesis with a level of confidence between 2 and 3 sigma, which translates to your 99 to 95% confident in your hypothesis. In the case of the luminiferous ether, there's many things we don't know about it. So let's use that as an example of what we can know about what we don't know. And another reason for using the ether as an example is that the theories of relativity are necessary solely to explain physical behavior without ether. This presentation is now about to begin identifying the important properties of the luminiferous ether. And I'll be demonstrating that those properties consistently determine the values of the fundamental constants of physics to a level of confidence that far exceeds 6 sigma. In other words, my goal for this presentation is to demonstrate that there is less than 1 chance in a billion that the ether does not exist and was not responsible for producing the fundamental constants of physics. So we need to get rid of the Michelson-Morley hypothesis and start with a much better hypothesis than they had. Ours needs to exclude their dubious theories about the Earth's velocities and other such nonsense that they were arguing in their paper. A better hypothesis would have been that luminiferous ether produces the fundamental constants of physics. And thus, the better null hypothesis would have been that luminiferous ether does not produce the fundamental constants of physics. That is a null hypothesis that meets the goal of being easily falsifiable. In other words, it is fairly easy to determine whether ether does or does not produce any given fundamental constant of physics. If the null hypothesis is false and we can reject it to a suitable level of confidence, we'll have that level of confidence the hypothesis is probably not wrong. And before I get into the details, I want to give a little bit of my background. 50 years ago this year, my job in the Air Force was to calibrate precision measurement equipment laboratory reference standards to meet what was then called the National Bureau of Standards. That bureau was the predecessor to NIST, which is an acronym the National Institute of Standards and Technology, and they assumed all the job functionality of the National Bureau of Standards. What I discovered in the laboratory is the major contributors to NIST exceptional accuracy and precision was the use of ratio measurements, and they also used a null meter that had no current flow when the ratios of things they were comparing were identical. And that's very analogous to no ether flow when the ratio of ether properties reach equilibrium. So you're going to be seeing a lot of that in the remaining slides. I'm pointing out example after example after example of where there's an equilibrium. So if subatomic particles really exist, we don't know whether they're ellipsoids or vortices or spinning disks or spewing streams. None of that really matters. It's important to think about what matters and what doesn't matter before a debate or before hypothesis testing begins. Despite not knowing the shape, we can know that the mass must be the volume times the density of the substance within that volume. And that is an inherent property of the definition of density as mass per volume. If you consult with AI or Wikipedia, they're going to do their best to convince you that determination of propagation speed is very complex. To quote Wolfgang Pauli, "Das ist nicht einmal falsch." And a good English translation of that is not even wrong. Pauli meant that as an insult for theories that couldn't be proven wrong. By using a null hypothesis, you can totally disregard the assertion of any debater that a problem is more complicated than you are making it. Because if the problem is more complicated than you are making it, then the null hypothesis will be true, thereby demonstrating that the hypothesis is wrong. On the left is an old equation for the propagation speed of waves in an ideal gas. It's from the days before modern physics factored in other effects like quantum mechanics. Its consequence is that pressure is equal to density times the square of the propagation velocity. So let's assume these equations apply to the luminiferous ether and the speed of light within that ether. And again, remember, the null hypothesis will be true and therefore not rejected if any of those assumptions are incorrect. The wonderful thing about a null hypothesis is that there is no need to debate nor validate any assumptions or hunches. It's either true or not true, and that's your goal. In Ether Roundtable 56, I thoroughly discussed how Kepler's third law produces the gravitational parameter for any given body. And that presentation used the ancient Greek letter kappa to represent the gravitational parameter, which is equal to the velocity squared times the radius of orbit for any satellite of the body being orbited. It's very important to realize that is not the only way to calculate the gravitational parameter, and that the gravitational parameter merely quantifies the presumed orbit of a satellite around a body. An example to observers assume they're on a globular Earth that spins on its own axis once per 86,164 seconds and revolves around the sun once per 365.25 days, a proportional sized glowing orb that's 26,610 kilometers above the center of that Earth would appear to orbit their globe once per day and thus be indistinguishable from the sun. And for any of you who want to do that math yourself, beware of the fact that the period must be half a day to appear to orbit that assumed rotating globe once per day. And that's because as the rotating orb, goes halfway around that rotating Earth. That rotating Earth is rotated out from under it. So it gets a little tricky. Think about that if you want to duplicate that calculation yourself. Another important thing to note is that the gravitational parameter is different for a flat Earth than for a globe Earth. And that's because the radius from the center is different, which means measurements of velocity and radius are all different if you do that calculation using velocity squared times radius. And in addition, the center of a globe Earth would be about 6,400 kilometers below ground level. So the altitude of the glowing orb above the surface of their Earth would be about 20,210 kilometers. A consequence of the gravitational parameter applied to the orbit of an unobstructed satellite is that a sufficiently low orbit must ultimately reach the speed of light. In other words, there must be a black hole at the core of all celestial bodies and all subatomic particles. So when Dr. Bennett reviewed this, he correctly argued that the implications of the phrase black hole make that poor terminology. For this presentation, I'm committed to use my inadequate terminology just to be sure that it's clear that I'm referring to the same general concept that people are referring to when they refer to a black hole. So perhaps in the future, I'll start calling it a luminiferous convergence or some other terminology that better distances itself from the errors and folklore that currently are associated with black holes. Nikola Tesla hinted at that when he described the whirling ether reverts to random ether when it transforms from matter to energy. So that indicates to me he got the concept even though it didn't really have a name at that time. In other words, mass consists of some volume that somehow encapsulates the ether, and the equation shows that the luminiferous radius of any given body is equal to its gravitational parameter divided by the speed of light squared. Throughout this presentation, remember that every time I talk about a luminiferous radius, that applies equally well to the semi-major axes of ellipsoids. Black holes have surface tension, and the surface tension of any black hole is its luminiferous radius times the pressure of the ether, or the density of the ether times the gravitational parameter of the black hole. In turn, that means the gravitational parameter of any black hole is its surface tension divided by the density of the ether, and the luminiferous radius of any black hole is its surface tension divided by the pressure of the ether. Since the mass of a black hole is its volume times the density of the ether, that equation can be reversed to find the luminiferous radius of the black hole from its mass. And that's what's shown by the equation that's in blue. What these equations and preceding equations during this presentation reveal is that if matter consists of vortices, there are vortices that behave like ellipsoids. And similarly, if matter consists of disks, holes, or slits, those disks, holes, or slits must spin fast enough to behave like ellipsoids. The left side of the top equation here shows how classical physics define the electron radius. What it actually represents is the radius at which an electron was presumed to be orbiting a proton and reaches the speed of light. In other words, the classical electron radius is equivalent to the luminiferous radius of a proton. And that enables us to calculate the volume of ether encapsulated within the bounds of a proton. Knowing that volume enables very accurate calculation of the density and pressure of the ether. And I'll demonstrate how to do that a few slides ahead. The color-coded expansions in the lower equation emphasize how the luminiferous ether produces each component of the classical electron radius. And it makes it obvious how all of those terms cancel each other, leaving only the luminiferous radius of the proton. The classical electron radius is crucial for accurate calibration of the properties of the luminiferous ether. But I didn't realize that yet when I first deduced the existence of the luminiferous ether. And please accept my apology for not yet explaining how the luminiferous ether produces each of these fundamental concepts. And also, please remember from few slides ago that the section symbol represents the 4 pi over 3 scalar that converts the radius cubed into the volume of an ellipsoid. And before we move on, notice the absence of any relativistic correction of the electron traveling at the speed of light. And you're not going to see relativistic corrections in any of these values, except I'll point out one known relativistic correction in a NIST value that actually made that a measured and then modified value deviate from what, very slightly deviate from what the ether predicts. Various equations from the prior slides lead to the top equation for the gravitational parameter of a proton. And like on the last slide, the color-coded expansions in the lower equation emphasize how the luminiferous ether produces each component of the gravitational parameter of the proton. And that makes it obvious how all of the terms cancel each other, leaving only the speed of light squared times the luminiferous radius of the proton. That last term is Kepler's third law, which applies equally well to the subatomic realm as it does to the cosmos. All of my data throughout this presentation were generated by a small JavaScript program that creates ether and NIST objects that are able to identify values and the variables that produce them. And that JavaScript program is available from GitHub. And if you get the presentation slide PDF, there's a link to that repository, or you can just search for it. By design and after considerable deliberation, the only units of measurement supported by my quick and dirty software are coulombs, kilombs, meters, and seconds. As demonstrated by the green units of this mass flux example, my software requires each unit to use a caret to separate it from a positive or negative exponent. So that shows you whether it's on top or bottom of a division. And those are followed by an asterisk to separate each unit from the next unit of measure. The upper right corner of this and all future slides will contain a blue equation to show how the ether produces each constant that's being presented. The text below the title of each slide shows the JavaScript objects and the mathematical operations applied to them. Besides not knowing the shape of subatomic particles, we also don't know what comprises luminiferous ether of which they consist. Ether might be made of neutrinos, it might be made of quantum fluctuations, hurtles all the way down. It might be pressurized bubbles boiling within the density of liquid ether, because we don't even know whether ether is a gas or a solid. Or it might be something else entirely. Despite what we don't know about ether, we can easily calculate the mass flux of the ether from NIST values for the mass of the proton, the speed of light, and the volume of the proton. The prior slide calculated the max flux of the ether solely for use as a calibration standard for the density and pressure of the ether. As this presentation will now begin to demonstrate, all of the fundamental constants of physics derive from the density and pressure of the ether. And density and pressure derive from the mass flux of the ether. And mass flux is the momentum of the ether per volume. I had this table in round table 56. This table illustrates how all of the fundamental constants of physics derive from the density and pressure of the ether. And by now it should be obvious there are many different ways to calculate luminiferous radii. Gravitational parameters, surface tension, etc. It's easy to view those attributes in this table as different measurements because each has its own unique measuring device. But a more careful examination reveals that these attributes are actually just different ways to view the momentum of ether particles. So just as water molecules in a bucket simultaneously exhibit all of these attributes and many more, ether contained within any volume simultaneously exhibits all of these attributes and many more. All of the values for the fundamental constants of physics for the remainder of this presentation derive from the properties of the ether. The speed of light is the square root of ether pressure divided by ether density. Although NIST declares the speed of light to be constant and exact, it is actually a very stable variable that's subject to Boyle's law. This presentation won't go into the impact of temperature, but it's important to realize that the speed of light depends on the temperature of the ether, in the same way the speed of sound depends on the temperature of the air. None of the physical constants are really constant. All are extremely stable variables. That's why ratio measurements and null meters are so important to NIST. And it has important implications for redshift, blue shift, cosmic microwave background radiation, the Hubble constant, and much more. The next few slides of this presentation will demonstrate that the only thing that really matters is the high accuracy to which we know the density and pressure of the ether. For all comparisons of ether values to NIST values, my software always stops at the first non-matching digit, even though the remaining digits may round to an exact match. The dark green digits on each slide represent at least a 6 sigma match that meets my goal for this presentation. In other words, the green digits indicate the null hypothesis is false and should be rejected. Blue digits represent a match that is well beyond my goal. This states the accuracy of all of their measurements inside parentheses at the end of the measured value. In this case, they're declaring the speed of light to be an exact value. And they did that so they could base all of their other standards on the speed of light. I think you may see other exact values, but all of those values they use as the basis for other constants, which is why they declared them to be exact. So the astute debater is going to point out that the speed of light was intentionally calibrated to be this accurate. So touche, I concede that point. Luminiferous radius of light is equal to the Compton wavelength, or the de Broglie wavelength for an electron traveling at the speed of light. In this example, NIST declares the last two digits of this value for the Compton wavelength are accurate to plus or minus 76. The green digits again indicate the null hypothesis is false and should be rejected, and the blue digits again represent a match well beyond my goal. Whether true or not, it can be argued that this too was essentially calibrated to be this accurate.
Hey, before we move on to the next slide, do you have a link to your GitHub?
Go ahead.
Somebody was asking in the chat.
I do. It's back on. Let me see which slide that was.
It's on the Prezi. I'll just link them the PDF if it's on there.
It's on the Prezi, and I can set that to you separately so you can link it more easily.
Oh, I got it already.
We'll find it.
Okay.
Yeah.
Yep.
Like how we said Prezi though.
So whether it's true or not, it can be argued that this too was essentially calibrated to be this accurate. Oops, I was off by one slide, I think. I already covered this one, right? You still hearing me?
Yep.
Yeah, you're good.
Oh yeah. All right, I'm not sure where I lost it, but okay. Moving on to the elementary charge. What we call the elementary charge was originally the Faraday constant divided by the Avogadro constant. And currently, this is one of the variables that NIST defines as an exact value. My software calculates the elementary charge as the square root of the quantity electron mass times the luminiferous radius of a proton times a conversion factor. And that conversion factor compensates for the fact that the original constants used the centimeter gram second system rather than the modern kilogram meters second system. That makes it off by a factor of 10 to the 7th power. Green digit, again, indicate the null hypothesis is false and should be rejected. And with this NIST constant or fundamental constant, finally we've reached a value that was not intentionally calibrated to be this accurate. And you'll see a really small deviation indicated in blue and black. The blue part that is better than what NIST states, and the black part is unknown. The mass of the electron and the luminiferous radius of the proton both derive solely from the density and pressure of the ether plus Kepler's third law. And notice in the conversion factor that the kilograms times meters is what converts the mass of the electron and the radius of the proton into coulombs squared. And that is going to be important when we reach the von Klitzing constant a few slides ahead. For those who are interested in dynamics and kinematics, these values are the kinematic and dynamic viscosities of light. For anyone who may be unfamiliar with kinematic viscosity, that is the fluid's internal resistance to flow under gravitational forces. I'll be using exclusively the kinematic viscosity of light in future equations. The kinematic viscosity of light is its gravitational parameter divided by the speed of light, which reduces to its luminiferous radius times the speed of light. And if you do the math, you'll see that's true. Pay close attention during the next few slides to understand how the kinematic viscosity of light influences very well-known physical constants that you may have never guessed were based on the viscosity of light. For example, what we commonly call the Planck constant is actually the mass of an electron times the kinematic viscosity of light. In other words, the Planck constant is the momentum of an electron times the luminiferous radius of light. Put that another way, so-called quantum levels are actually the momentum of a single electron oscillating at the luminiferous radius of light. Green digits indicate the null hypothesis is false and should be rejected, and as usual, the blue digits represent a match well beyond my goal. The Planck constant represents the physical resistance of light to electron flow. Now we're at the von Klitzing constant, and that is actually the Planck constant divided by the elementary charge squared to express the electron's physical resistance as an electrical resistance in ohms. In other words, electrical resistance is physical resistance for elementary charge squared. Green digits indicate the null hypothesis is false and should be rejected. The red digits represent the deviation of the ether value for this constant from the NIST value. I suspect that that deviation results from a serious problem that has overtaken the physics community. And that's exemplified by an abstract from volume 54, issue 3 of Physics Today. And if you get the PDF slides, they quote this abstract, and they also have a link to where you can find it to check it out yourself. But what the abstract says is the best values of the fundamental constants can rarely be determined by direct measurement. Instead, are usually found at the end of a chain of experimental observations and theoretical relationships. In other words, they're justifying fudging the data. Instead of giving you what they really measured, they're adjusting it for relativistic effects so they can support the theory of relativity. What we commonly call the Bohr magneton is actually the kinematic viscosity of light times the elementary charge divided by 4 pi. In other words, the Bohr magneton is actually the kinetic I'm having trouble with that word tonight. It's actually the kinematic viscosity of light converted into joules per Tesla. And the green digits indicate the null hypothesis is false and should be rejected, so the ether does predict this value. What we commonly call the Bohr radius is actually the quantity luminiferous radius of light over 2 pi squared, that quantity divided by the luminiferous radius of the proton. For this constant, there's a slight discrepancy starting at the 11th digit. It's well within this stated accuracy, indicated by the blue digits as usual because it's within their stated accuracy. The green digits indicate the null hypothesis is false and should be rejected. What we commonly call the fine structure constant is actually the velocity of an electron in orbit, the Bohr radius divided by the speed of light. After refactoring and eliminating common terms, those velocities reduce the circumference of a proton divided by the luminiferous radius of light. The red digits represent the deviation of the ether value for this constant that exceeds this stated accuracy. This is another case where I suspect this deviation results from NIST adjusting the measured values to conform to erroneous theories. But despite that adjustment, the green digits indicate the null hypothesis is false and should be rejected, so that the hypothesis is still true. The luminiferous ether is what's producing all of these physical constants. What we commonly call the electron mass is actually the density of the ether times the volume of the electron. The green digits indicate the null hypothesis is false and should be rejected. What we commonly call the proton mass is actually the density of the ether times the volume of the proton. The green digits indicate the null hypothesis is false and should be rejected. Here's where things start getting interesting. What we commonly call the Hartree energy is actually the mass of an electron times the gravitational parameter of a proton divided by the Bohr radius. This value determined by the ether exceeds the stated uncertainty of the NIST measured value as identified by the red digits. So despite that deviation, green digits indicate the null hypothesis is false and should be rejected, and that is still to a 6 sigma level of confidence. I only recently discovered that for this particular discrepancy, NIST admits they definitely modified their measured value by applying complex theoretical calculations to account for small corrections due to relativistic effects and other quantum mechanical factors. So in other words, this discrepancy exists because NIST modified its measured value to conform to widely accepted erroneous theories.
Wow.
And that point is particularly relevant when you're debating globers about area success, because the relativity they want to invoke to transform success into failure is now beginning to infect NIST and motivating them to intentionally manipulate measurements. That's not only fraudulent, it's also the height of folly. manipulate actual measurements to conform to popular theories, no matter how accurate those theories may seem to be. But that's exactly what our government has been doing. What we commonly call the electrostatic force is actually the Hartree energy divided by the Bohr radius. The discrepancy for the ether value of this constant is well within this stated accuracy, as indicated by the blue digits. The green digits indicate the null hypothesis is false and should be rejected. And notice this, what the ether predicts for this value is based on the Hartree energy, which NIST got wrong, and yet this measurement is within their stated accuracy. And that's because they didn't, well, they should have realized this was based on the Hartree energy, so I can't imagine why they didn't fudge this too. What we call the characteristic impedance of a vacuum is the mass of an electron times the kinematic viscosity of a proton. So before, when we were talking about von Klitzing constant, that was times the kinematic viscosity of light. In the case of vacuum impedance, it's the electron mass times the kinematic viscosity of a proton. And note that division by the elementary charge squared over 4 pi expresses that physical impedance as electrical ohms. Discrepancy for the ether value is constant to within this stated accuracy, and the blue digits indicate that. The green digits indicate the null hypothesis is false and should be rejected. I'm going to take a sip of hot cocoa. It's cold here. It's about 20 degrees out. What we commonly call the vacuum permeability reduces to 4 pi divided by CGS to MKS conversion factor that I talked about back during the elementary charge. And compare this equation to the elementary charge if that doesn't make sense. The red digits represent the deviation in ether value for this constant that exceeds this stated accuracy. But despite that deviation, the green digits indicate the null hypothesis is still false and should still be rejected.
Can you go back to that slide just for a sec?
Certainly. Sorry for
For simplicity's sake, I wanted to use this particular slide to address the point in mind. And it has to do with your units of measurement. I don't mind that you're using K instead of kilogram. I mean, it's less intuitive, but convertible in the mind. But when you express a unit of measurement like that, do you think it would be better, or do you think you could manage in the future to order them according to their exponential value, largest to smallest, as in this unit of measurement should actually read kilogram meters per squared coulomb? So you would write it K up 1, M up 1 times C up -2. Does that make more intuitive sense to you?
So I'll definitely concede your point. And this was quick and dirty software I did. And when I had to order variables, it made the software a lot more complex. When I had to teach it not to look for a single letter for a unit, but to look for multiple letters and distinguish, that made it more complex. So to keep the software very easy and simple, I took those shortcuts, and I actually originated this software during a conversation I was having with Fractal Woman, just to prove to her that this could be done. And as far as I know, that conversation is in no way public, but she and I were talking about it, and it was actually her who motivated me to write this software in the first place. So with all the time I spend on dog rescue, I won't be able to do that anytime soon, but it's out there on GitHub for anybody who wants to modify it, and I will gladly publish anybody else's modification. And someday I'll try to accommodate your request because what you're saying is totally reasonable, and I agree with you.
That's awesome. Thank you for getting that far. But in your explanation, you kind of made it sound like your software is dictating the format of your presentation, where you have no control over the display of the unit in this slide here. And that's where I would take you to task.
Okay, so I'll concede that point. Also, I was lazy. This was a
Yeah,
copy and
smiley face, but you know what I'm saying, right? Okay.
I know exactly what you were saying. This was a copy and paste directly out of the output from the software, and I was too lazy to put things in the right order and add the missing G and get rid of the carrots and get rid of the asterisk.
He's like, you got me. You got me. Listen, I
All
didn't
right.
do.
Now we're going somewhere. Now we're
This
going
is
somewhere.
another.
All right.
This is definitely another touche moment. You definitely got me here, and I concede your point.
I have a quick question, sir.
Certainly.
I had to drop out for a second and come back, so I missed a little bit of a chunk in the middle. But these values that you're comparing between, Ether predicted value and NIST measured value, or NIST published value rather, well, these are based on the formulas that you're giving above from these Ether fundamental constants that you've derived or someone's derived. What are these derived from?
These are in my book about the luminiferous ether. There's an appendix. I don't remember what the appendix letter is, but it shows the derivation of how I came up with all of these. And as I was realizing that what I wrote, I in my earlier book, Ramblings of an Old Man about the Scientific Method, I came up with a bunch of stuff that ultimately I realized it was luminiferous ether that was causing all of that. And then in the book about the luminiferous ether, that's where I started rederiving all of those equations in terms of the ether. And so it's kind of a long, involved trial and error process to figure all this stuff out. So what I'm really showing you is the end result. And if you want to see the painful process I went through to get here, look in the appendices of my book about the luminiferous ether. And for anybody who has Kindle Unlimited, you can get that book free from Amazon. You can borrow it free.
Perfect.
And
oh, sorry, go ahead. Sorry.
And I was just, the only thing I was going to add is that occasionally Amazon even runs free promotional, so every now and then you can actually buy it free, but definitely anytime you can borrow it free.
Or buy
Okay.
it. Go support them.
And
I'm okay with that too.
the other thing was a lot of these formulas invoked the mass of an electron or the radius of a proton. What do you define an electron and a proton as in an etheric model? Because maybe you said that and I just missed it. I'm sorry.
And I think I definitely talk about that in the book. I think I talked about that a little in the prior presentation. But basically, to find each of those, the first thing I do is use Kepler's third law to find the luminiferous radius of whatever that alleged particle is. So for the proton, I eventually discovered that was what physicists call the classical radius of a electron. That's really the radius of a proton. Light is a lot trickier, and you'll probably have to refer to all the stuff I put in my appendices about derivations to figure out how I determined that was actually the Compton wavelength or the de Broglie wavelength for an electron traveling at the speed of light, which are those are one and the same, and those are both in reality those are both luminiferous radius of light. And my book also explains much better why light has a luminiferous radius, because you would think an oscillation of waves through the ether should not have a luminiferous radius, but that's because within those oscillations is contained a very well-defined mass. It's constant, in fact, and the book does describe that. And because of that constant mass, light has all of the characteristics an electron or a proton would have. But of course, they're different values, but it's the same concept. It's just a mass that's contained within the luminiferous ether instead of by whirling ether being contained like an electron or a proton is. Light's contained by the oscillation of the light wave.
I think I'm tracking all that. Specifically, ontologically, do you have an idea what an electron is or what a proton is? It sounded like maybe there was something vortexual in the nature involved, but I'm not sure what.
So this goes back. This goes back to my introduction at the beginning of this presentation, where I said maybe it's a real particle, maybe it's a whirling sphere, maybe it's a rotating vortex, maybe it's a spinning disk, maybe it's like that hose the fireman was holding and it's just whipping around, but it whips around in the shape of an ellipsoid. So the only thing I can say with certainty is whatever an electron or a proton or light itself is, it is something that behaves like an ellipsoid, independent of whatever it actually is. So I think what particles are, what light is, are still a good topic for future research by any budding physicist.
Hey, Pizzo, just to get you there mentally from A to B in a succinct way, I would just tack it up to ladders of presumption and just go from there.
I got you. Thanks for thank you, Stone. Thanks for asking or answering my questions, Dr. Mike. I appreciate it. That it gives me a pretty solid understanding of what you're laying down here.
Yep, and thanks, Stone, for helping make up for the fact that I'm still coming up to speed on how to talk to you guys.
Not to worry, not to worry. Okay, let's keep it rolling, I guess.
And I'm sure I should have said, instead of guys, I should have said lads and ladettes.
Nice, dude. He's adopting the vernacular well.
I'm trying to learn. What we commonly call the vacuum permittivity, and in the prior presentation, I pointed out that goes by other names like the electric constant or the distributive capacitance of free space. That is actually the reciprocal of the electron mass times the gravitational parameter of a proton. I should have said that's actually the reciprocal of the quantity electron mass times the gravitational parameter of a proton. And that is then multiplied by the elementary charge squared over 4 pi and converted into electrical units. The red digits represent the deviation of the ether predicted value that exceeds this stated accuracy. But again, the green digits indicate the null hypothesis is false and should be rejected. So did we cover the both electric and yeah, we did. Okay. Let's take a brief pause now that it's become obvious the luminiferous ether is responsible for electromagnetism. If you didn't already recognize this before now, the luminiferous ether achieves the holy grail of physics by unifying gravity with the other fundamental forces. And that's a logical deduction based upon the fact that electromagnetism was previously unified with the other forces. The luminiferous ether explains electromagnetism, and the luminiferous ether explains gravity. The gravitational parameter of the Earth in particular is known so accurately because it's crucial for calculations related to orbital mechanics, and especially when dealing with satellites orbiting the Earth. The gravitational parameter of the Earth implies the black hole within the Earth has a luminiferous radius of 4.435 millimeters. And that means external ether is essentially flowing perpendicular to the surface of the Earth as it drains into that black hole. Thus, it was very bad assumptions that caused Michelson-Morley experiment to fail so badly. And that's why a good hypothesis is so important to focus. Pardon me for a moment. I'm going to pause a Roborock that started cleaning the floor in the vacuum.
We can't hear it, by the way.
Amen to crisp noise canceling.
Yeah, I'm impressed with the noise canceling ability of this microphone. It will get pretty loud, so I'm gonna just pause it. Okay, it's paused. So the bad assumptions that Michelson-Morley made about what the ether is doing is why a good null hypothesis is so important to focus you on what you're trying to refute. In many ways, Michelson and Morley were essentially riding in a boxcar of the train while they were trying to measure the Doppler shift of the train's whistle. That was a really stupid thing to do. And they didn't realize that's what they're. And again, we need to cut them some slack because this was before Gossett invented small sample hypothesis testing. But because they didn't have a good null hypothesis, they lost focus of what it was they were actually arguing. Now, moving back to physical constants, what we commonly call the magnetic flux quantum is actually the mass of an electron times the kinematic viscosity of light divided by 2 times the elementary charge. The red digits represent the deviation of the ether value for this constant that exceeds this stated accuracy. And this is another case where I just suspect that's because they've started fudging their numbers to agree with relativity and quantum mechanics. But despite those wrong digits, the green digits indicate the null hypothesis is false and should be rejected. What we commonly call the Josephson constant, which is important to the Josephson junction in supercomputers, is actually 2 times the elementary charge divided by the Planck constant. The red digits represent the deviation of the ether value for this constant that exceeds the stated accuracy, and the green digits indicate the null hypothesis is false and should be rejected. What we commonly call the Rydberg constant is actually the radius of a proton divided by the quantity 2 times the Bohr radius times the luminiferous radius of light. And again, the red digits represent the deviation from NIST, and the green digits indicate the null hypothesis is false and should be rejected. So, this is the end of explaining the physical constants. For all of those physical constants, the null hypothesis is false and must be rejected beyond the 6 sigma level of confidence. In other words, the luminiferous ether does produce the fundamental constants of physics, a level of confidence that exceeds 6 sigma. And moreover, the luminiferous ether unifies gravity with the other fundamental forces of physics. And in addition, the relativistic corrections are not required for any of these constants, and they appear to actually corrupt the measured data whenever misapplied them, thereby casting extreme doubt on the theories of relativity and everything based on those theories. Here's my suggestion for debates with Globers. Let flat Earth be the null hypothesis, and ask them to use curvature of the Earth measurements to reject the null hypothesis. And demand actual measurements, not distorted photos, not theories, actual measurements. And they produce sufficient evidence to reject the null hypothesis? So far, I haven't seen it. Challenge their false claims by focusing them on rejecting the null hypothesis. And don't feel like you need to reject a globe Earth null hypothesis to prove flat Earth to the Globers, but if you do, be aware of dam and lake measurements, bottom-up resolution loss, extremely high altitude balloon videos, and there's much more that you can use to reject a globe Earth null hypothesis. Something I particularly like about extremely high altitude balloon videos is that if you watch closely, the wobble of the balloon exposes any optical distortion above or below the flat horizon. And you can see the horizon bowing up, bowing down, bowing up, bowing down. And that tells you they're using camera tricks.
Classic camera trick with the old high altitude balloon. You hate to see it.
Yep. So is the final experiment really final? So I'll answer that with another question. Is it ever wise to stop seeking the truth because you think you found the answer? What unknowns remain to be discovered? And ask yourself, what did the sponsor fail to consider? So sadly, the absence of a 24-hour sun was a theory promoted by many people, and the sponsor wants to focus on that. It's best to dismiss that and all straw man assertions and refocus the Globers on rejecting the null hypothesis. If you can't resist debating Globers about the 24-hour sun, my recommendation is use the null hypothesis of the 24-hour sun is not possible on a flat Earth, and then select your most confident way to falsify that null hypothesis. So,
dude, you're amazing. Dude, you just connected the other half of what I'm working on for Friday, dude. That's incredible.
Oh, good. I'm glad I've been of some small help. So two ways I immediately thought of you can do that is either reject their null hypothesis because there was a 24-hour sun and the Earth is flat, as demonstrated by curvature measurements, or another way you can reject their null hypothesis is because actual observations match flat Earth azimuth and elevation predictions. And of course, we'll have to wait till the data comes flowing in to do that. And it's up. It should be fun. It's up to each of us to determine what level of confidence is acceptable, but I would suggest at least 2 to 3 sigma, which is about 95 to 99%. And the nice thing about that is that puts you up with doctoral students. That's the level of confidence that they go for. So artificial intelligence has already demonstrated its inability to think rationally. One area where AI seems to truly excel is telling you the mainstream talking points for anything you ask. So use that to your advantage by asking questions and dealing first with the answers that are most difficult to refute. And then my final piece of advice is don't let your heart be troubled about anything about which you are uncertain. Just don't worry about it. We can know things despite what we don't know. So, are there any questions?
No,
Well,
man,
Dr. Mike,
that was fantastic.
I just wanted to say thank you for the presentation. That was fantastic. I can't wait to see what where Alan goes with it for this upcoming Flat Earth Fridays. And then I wanted to drop one tiny bit of information for folks if they have never heard of this. You've seen people in the community, in the truth-seeking community, that is completely against the ether. They don't want to believe in it. They're opposed to it. And some people even hate Witsit with all their heart because he believes there is an ether. I was shocked that there's some folks that they tie the deceiver, you know how Satan is the light bringer, they tie the ether into him. And that really blew my mind because I see the ether more akin to the Holy Spirit, more the background medium that permeates everything. I see the ether as beautiful and wonderful, and it's necessary for life. But you know, when you see people that are vehemently against the ether, they may just be confused. So just be patient with them, because everybody's trying to figure it out, and a lot of people don't really know what's going on. But I'm glad this is happening. Thank you for your talk. It was epic.
I'm happy to contribute, and a shout out again to Cass and Eric for making good suggestions, and also to Pizzo because I was really inspired by how calmly he handled McToon.
I thought that you were inspired by trying to flex on your friend for a slight bet for a minuscule reward. I thought that was the pretense for the whole presentation, which I also thought was hilarious. Many good things have come from frivolous natures of that. I'm just gonna say.
I do have a
Thank
question.
you, Dr. Mike. I appreciate it. It was first time interacting with him. It was just a conversation, but
Was that your first time?
Well, second time. First time was talking to him and telling him he was weird on EA for like calling Witsit a liar about the lawyer stuff or whatever. But that was my first time actually having a real interaction with him.
Yeah, I'd say you get the real treatment. You get the orange cat deflection, the absolute obfuscation, the ridiculous relativity claim that everything's relative and you don't understand it, the super gaslight that you don't understand it, and then finally the willful disengagement because you threatened his very position with all the measurements and the math, and then he sees the frivolous interruption from somebody else to try and dismiss you completely right before dismissing your god with a shrug and a smirk. It was kind of gross.
Yeah, it makes me feel bad for you guys having to actually debate him formally because it's like, geez. But Dr. Mike, whenever they wrap the presentation, the stream up, if you hang around for a couple minutes after we're off air, I have an extra question or two for you once we finish here.
Yes,
I'll be here.
I have questions too, with some
Go ahead,
comments.
Cass.
Nice.
Mike, I think you picked a great topic because these guys just love to debate. They're so motivated, they'll even go to Antarctica in order to experimentally prove their position. And to tell you the truth, I wouldn't go to Antarctica to prove that special relativity is wrong, but that's because I don't have the motivation that these guys do.
I mean, would you go, Alan? Because I don't know if I would go to prove relativity. I think I could do it from here. To be quite honest for you,
I would.
Do or die for alpha.
Yep.
Yeah, this is a great talk, Mike. The plans that we have, I think we can reveal. We've got together offline, looked at Ether model from my viewpoint, which has basically been presented with the Hildegard presentations, which is a view of the ether from a revealed point of view. And it starts at the edge of the universe, as you know, and works its way in to eventually the experiments that are possible from the Earth's surface. It was a great revelation to see Mike's work, where he exposed the point of view of ether as reflected in the fundamental constants of nature. It's sort of like the answer was right in front of my eyes, and I never saw it, never realized it. One problem I have is all of the digits that I see being displayed, up to 10 or up to 10 significant figures, just staggers me in terms of the normal range of accuracy that I deal with. I'm happy to have an order of magnitude accuracy in comparing experiment and theoretical predictions. So yeah, we're planning to put together a joint presentation where I would present the high-level view, that is the cosmic view, working my way from the edge of the universe, essentially, back down to the Earth. And then we would switch to Mike's view, which has been presented, I think, at least twice, and it's certainly stated well in his 2 books, and sort of make the ether model truly universal. That's the plans, at least, and we'll see how that works out. I do have, as I said, some commentary and some questions. I wrote down by page. I think on page 6 is the introduction of a shape form or shape dependence, and I think that's a great way of getting away from discussing what the shape of the ether is in all of its bound forms. I think you can separate ether into unbound, which is also called free ether. It's a plenum or a continuum. It fills all of space. There are no gaps. And you can distinguish that from bound ether, in which ether is localized and stable. And you can distinguish the free ether from the bound ether by its motion. That was a question that came up. What exactly is our belief about the ether? So shape dependence only adds possibly a factor of pi or something like that to the actual values of the constants. Once you decide what the shape model is, then you can determine what that particular factor is. But your order of magnitude for these constants should be in agreement with any kind of shape model.
So this is one of those things. Oh, if I could just interrupt momentarily,
Yeah,
while you're
go.
on page 6. So that's why I advocate for the null hypothesis. You don't really have to prove any assumptions or hunches, and so what the null hypothesis did in reality is I admit up front I have no idea what the shape of the ether is for particles or for light. What I can know with certainty, or to a 6 sigma level of confidence, is that it behaves like it's an ellipsoid, whatever form it might be taking. It could be a blob that behaves like an ellipsoid. We really don't know. But some of those NIST values, they claim to be accurate to 13 digits. And you can see my data to all 15 digits match their data. So, and that's why I use so darn many digits, which seemed like gross overkill. But since they were claiming that level of accuracy, I just went 2 digits beyond them to show that it rounds up to their value. But it does that despite not knowing what the shape is. And I agree with you completely on free ether versus bound ether. And I'll mute my mic now so you can continue.
Yeah. Let me just write something down here. Yeah, on page 7, we have a mention of the MMX. Can you go back to that so we can see that screen?
I was just
Or
about to ask Dr. Bennett. Yeah, if you could go back through the slide, if you could, Dr. Michael, that'd be great.
Okay, that would be slide 7.
Yes.
yeah, it's page 7 on the PDF.
Oh,
Yeah.
page 7. So the pages don't necessarily correspond with the slides. Is this the what's the title on the slide?
I didn't write that down. Just the page number.
Okay, if you start talking about it, I'll figure out which one it is and pull it up.
Oh, about shape dependence, there are some models that say that the bound state of an ether is a toroid. That's quite common. Besides the ellipsoid, is a toroid or donut shape. In fact, there's another one in which you have two toroids rotating to produce spin in one direction and counter-rotating to indicate a spin 0 particle. Have all kinds of shape models and different types of motion internally to model it. That's why I like that shape form that you use, so that you don't get involved in the details of what the shape of the bound state is, but you want to know what are the measurable properties, which you've outlined nicely in the talk, and the focus is where it should be on what are the visible properties of the ether, which will confirm the model. If that's page 7, then I'm not sure what my comment was. Let me just say that I noticed that MMX was noted, and that the mainstream has rejected MMX, of course. And I think it goes back to a historical problem when Copernicus and Galileo proposed the heliocentric model. About 30 or 40 years later, Tycho Brahe introduced his response, which was a geocentric model in which the sun and the moon are the primary satellites of the Earth, and then the planets are secondary satellites of the, or primary satellites of the sun, secondary satellites of the Earth, and then you have the moons, which are the third level. So what they did when Tycho Brahe introduced his model was try to ignore it, just like they ignore all of the rebuttals to special relativity that are presented today. So the reason for rejecting the MMX may go back as far as carrying on the rejection of the Tychonian model. And you go to page 13, which introduces, I think, the speed of light for the first time.
Is that the right slide?
Yeah, that's it. Now, the question there is, reading of Tesla, we know that he introduced the concept of a longitudinal wave, longitudinal electromagnetic wave, light, and it traveled at a higher speed, much higher speed than the speed of light. Matsutowski categorizes light speed as having two values. He calls it C1 and C2. C1 is what we would call the value of C, 8 times 10 to the 8th meters per second. The speed of light, when it propagates as Tesla imagined longitudinally, would be about 10 to the 14 times faster than that. So there are two speeds of light, if we follow that reasoning, that we can plug into that formula for pressure over density. If the second speed, C2, is much greater than C1, the normal speed of light, and it means that either the pressure has increased and the density decreased compared to the normal speed, or both of them have changed. In any case, that's one of the things that I know have to be resolved. Are there really two speeds of light? And does this relate to the problem that we have of the dual nature of light? That is, sometimes it acts like a wave, sometimes it tests as a particle. I think that the particle presentation that light gives is when it is speeding at the Tesla light speed. And I think that when it's acting as a transverse wave, obeying Maxwell's laws, that's when it obeys the double split experiment. So this is an issue that I would have to resolve at the time we do the joint talk, examine the possibility of a second speed for light, which represents its longitudinal speed, and see how that affects the reasoning that went into your presentation. Any response?
We can either try to resolve it, or if we can't resolve it, we can just state that this is what he said, and at the moment we can't resolve it. But I'm definitely in favor of discussing these things and identifying what we know, identifying what we don't know, but realizing we don't have to know everything to go on and make useful contributions.
Hey, good. You have page 17, it looks like. I think you first introduced black holes. Okay, that's good enough.
Is that it?
Yeah, anything that says black holes.
I think this is where it first got introduced.
Okay. My objection to black holes is that it conjures up the image of a solution to Einstein's general relativity field equations, in which it is claimed that the collapsing of space can reach a point where light cannot even escape. And they claim experimental evidence for this because when they look at the center area of galaxies, they typically find a void, that is an area in which there is no visible light being produced. And being a galaxy, let's say a spiral galaxy, it is rotating, so they have the motion of stars around the center void. And they say, aha, that's a black hole. Theory says that nothing can escape a black hole, which means not just light, but any electromagnetic radiation. Now they have measurements for the cosmic microwave background, which are in the microwave region of the EM spectrum. And it doesn't have the resolution, I don't think, to detect whether there is any CMB, that is, any microwave radiation being emitted from the the alleged black hole. But that's one of the reasons why when you use a term like black hole, it associates with it that there was experimental confirmation. This is often used as confirmation of Einstein's theory of general relativity. So just making a name change is what I suggested in order to avoid this implication that we're agreeing with black holes as a solution of the general relativity field equations. And what did I suggest? Black vortex. Maybe that would be something that would be suggestive of rotating ether. And whether it's black or not, that just agrees with the common prefix now that whenever something is unknown, it's just called black, or in this case, the light doesn't escape from it. So that was my objection to the use of black holes as a name, because I think it can produce confusion in the reader that we're agreeing with the classical conception of black holes. Okay, on page 21, we have S flux equation.
So before you go on to the next one, I agree with you completely on that. Like I said on that slide, I know that's the wrong term to use, and for the moment, I'm committed to the term only because I want to make it clear that we're talking about the same thing. But I agree with you. We need to change the term because everything they say about black holes is incorrect. And one of those incorrect things, in my opinion, is that they're not even black. That light can easily pass right through a black hole. And in fact, that may be why light slows down in water. As it's passing through all the black holes, it's bound to hit on its way through the water. But there's a lot of unknowns, but we're in total agreement on changing the name.
Okay. Yeah, on page 21, there's a mass flux equation. And well, the only point there is it involves using the speed of light. In fact, in any equation that you use, if we do find that there is a validity to using C2 as the speed of light or a Tesla type wave, that would be reflected in all of the units that depend on C or C squared.
So I think probably the best way to think of the speed of light is as a group velocity. Because even within a pressure, not all the, let's take air pressure for an example. Not all of the air is colliding at the same velocity. And yet, if we put a tire pressure gauge on there, say it's in a tire, we'll measure a pressure, but that doesn't mean every molecule in that tire is propagating at speed of sound. It's more of a group velocity. And in fact, especially if you're using air to fill your tire, the velocity of nitrogen is different than the velocity of oxygen. Nitrogen being a lighter molecule will have a higher velocity. Oxygen being a heavier molecule will have a slower velocity. so that overall the momentum of the gliding particles averages out to something. And I think that's exactly what's going on with light. So I don't even think you really necessarily need a C1 and a C2. If you wanted to differentiate for some reason, you could certainly use a C1 and C2. But I view the C as I've been presenting it as being the group velocity that probably includes both C1 and C2.
Yeah, of course, I would require experimental confirmation. Atsukowski claims the value that I cited, 10 to the 15 times C. And I haven't had the time to examine how we derived that, but that's what I would do before we actually did a presentation so that we can resolve the issue experimentally, as always. I have a question about your use of standards. You used the NIST standards. You referred to the fractal gal. She has some modifications to NIST, which are basically due to the absence of an indication that when velocity is used, it refers to rim speed, not linear speed. So there's a 2 pi involved. There's a radian measure, which is unitless, but should be used to indicate when you state a velocity, it includes, or it refers to, the radial component, excuse me, the tangential component, the rim speed, rather than a linear speed. There's the Planck units, and then there's Atsukowski. So we have 4 so-called standards. NIST, Fractal Gal calls it MUA, and we have Planck and Atsukowski. And the preparation for the talk, to my mind, would require that we indicate if we can eliminate any of those. I know you picked the NIST for good reasons, and all we have to do is establish that the other candidates for standards are invalid for one reason or another. On page 23, you have a chart. I think it's worthwhile if you can put that up. You have a table of velocities. Yeah, that's it. Now, Fractal Gal does an interesting thing. She extends your table by adding, multiplying by velocity for a third time to produce units of kilogram meter cubed over second cubed. And the way she argues that this has physical meaning is that mass is static inertia, momentum is kinetic inertia, energy is a higher level of kinetic inertia. And then this units that I just mentioned, kilograms over velocity cubed, excuse me, times velocity cubed, that represents inertia, excuse me, ether inertia. And she has some reasonable arguments for using that as a measurement of ether resistance to change. That is inertia. And I would consider that in our presentation to address it as either credible or not, and see if that leads to any new conclusions, just like your analysis of the Kepler third law constant, you call it the gravitational potential, how that leads to some very interesting results. In fact, it leads and supports almost all of the work that you've presented here. Kepler third law, by the way, was the way that I got introduced to my Aether model, because in kinematics, I found that there are only a few laws that you can derive, you can measure experimentally that are independent of the reference frame. And one of them, the centripetal force. You can mathematically derive the centripetal force required to keep something moving in a circle as v squared over r. And that is independent of any physical assumption about what the mass is, whether it has internal rotation, energy, anything else. In other words, this is a true abstraction of a mathematical truth from nature, from just observation of motion. So c equals v squared over r is a kinematic derivation that seems to indicate that no matter what the physical world was composed of, it must obey that particular law. Anything moving in a circle, in other words, in the physical world, must obey that law. So that sounds very much like something that is universal, that is causing this, that is the ether. The other experimental or empirical observation is Kepler's third law, in which we find that there is a relationship between the radius of an orbit cubed and the period of its rotation squared. Now, there's a Kepler constant involved that typically in mainstream work includes the mass of the sun when applied to the solar system. But it's very interesting that if you use so-called natural units, if you use the astronomical unit, AU, which is the distance between the center of the sun and the center of the earth, and you use the observed period of the sun, which is 365.25 days. If you use the AU, yearly period of the sun's orbit, you get Kepler's constant equal to 1. So there we have, just like my work with the absolute lab frame, discovering that the laws of physics are only valid on the Earth, here we have a law that says the ether is probably involved here because we have something that is independent of any physical constants. That is, r cubed is equal to t squared. Not proportional to, but equal to, if we use the natural units. The natural units would be used if you were a visitor from outer space and you came to the solar system and you said, well, what units should I use to measure the motion of the planets and the sun and the moon? Well, I'll use the distance to the center of mass, which is the sun. That gives you the AU, the astronomical unit. use the time that it takes for the orbiting satellites to complete a complete revolution, which is 365 days for the sun. That would be a natural unit then for anyone who had a cosmic view, an overall view of the solar system. So all of these things, of course, have religious undercurrents. Okay, why is the Earth the only one in which the Kepler constant is 1? Okay, why is the absolute lab frame the Earth frame? Why do the laws of physics only valid? Why are they only valid if you make your measurements from Earth, if the observer is in the Earth frame? Otherwise, the laws of physics are invalid. So all of these things point to something beyond physics, certainly, something that is immaterial. And as long as we limit ourselves to discussions of the ether, we need not get into that area. But I did want to bring it up because that's the first thing that strikes me when I see the centripetal force law and Kepler's law being independent of any physical constants. On page 23, I already covered that. Page 28, let's see. Page 28, I think you define the value of the kinematic and dynamic viscosities. They don't agree with Katsukowski's constants. They both are they are both low compared to the other constants, which usually have huge orders of magnitude. I know that in one of your books, you say that the viscosities are 0. I don't know if you meant approximately 0 or 0 for the purposes of that area where you were discussing it. But it is,
So
is it you?
just so I could jump in and answer that right away. Is only the viscosity of the ether itself is 0, because the ether is a superfluid. When it's contained or bound in a particle or in a light wave, only then does it have viscosity relative to other particles trying to pass through.
I see. So that's an important distinction. Okay, that clears that up. And I think that's all I have to comment on. I look forward to working with you on putting this together in a coherent way, and we'll give a presentation to the Ether rebels here, and let's see where this is destined to go. But thanks for the presentation.
And thanks for your patience in working with me, and I look forward to working together also.
Good.
Questions, Dr. Bennett. Could I ask you a question real quick, Dr. Mike?
Yes, sir.
Always.
So you said you worked with NIST for 50 plus years or 20 plus years. I can't remember exactly what you said, but
50 years ago, while I was in the Air Force, I was NCOIC of lab standards. And so I worked with the National Bureau of Standards at the time to calibrate all the reference standards we used in that laboratory.
National Bureau of Standards, that was what NIST was beforehand, right?
Right. That's the organization that ultimately became NIST.
Gotcha. And that's what made you kind of dive into the fundamentals of Ether. You were seeing the similarities.
No, actually, that's as with many things in my life. That's I think we never see the invisible hand of God as it's guiding us through life, and we don't know why we go through certain experiences we go through. But that's something I recognized after the fact. Oh, that applies to this.
Right. Okay. I just found that fascinating. But yeah, great presentation, or Prezi, as the boys call it.
Yo, Pizio left me with a question. He had to go, but he typed it out. He wanted me to ask you. I don't know if you're familiar, but I'll put the text in the chat so you can look at it. But if you're familiar with the Fresnel drag formula, and why how Fresnel dragged it, or how he dragged it, why he derived it, or how he derived it, he ends up saying that the density of the ether in a medium will be proportional to the square of the refractive index of that medium. And so Pizio's question was, when you derived the density of the ether, he said basically the refractive index of a measured or condensedness of ether in a material body, since the speed of light is based on the pressure of the ether, this is why the refractive index causes the light to slow down. So basically the relationship with the speed in a medium being a factor of the compactness of the ether in the medium. So like that density changing.
I haven't looked into that specifically. So that'll definitely be a topic for future research, I think.
Nice. Yeah. Okay, cool. I put the formula in the chat, so just check it out whenever.
I was looking at it while you were talking, and it all looks valid, but I'm not that familiar with it. I mean, I'm acquainted with it, but I haven't studied it as thoroughly as I've studied a lot of other things, and so I'm just not sure how to answer that question. But it's definitely worth looking into. So I'll definitely try to look into it.
Word. All right. Does anyone else have any questions or comments?
Could you, if it's possible for you to get your hands on, could you get the relativistic calculations that they were trying to introduce in order to keep that paradigm alive, but that ultimately failed when applied to real standards? Do you have an idea of where that would be?
I don't have an idea where it would be, like I mentioned on that slide, I only just recently discovered that, so I'm gonna have to do some digging. They're pretty good at publishing what they're doing and why they're doing, so I'll have to just dig around on their website to see what what if anything they've published about it, and then I'll try to give you a better answer after if I can find it.
Oh yeah, perfect. I didn't know it was a recent discovery. That's awesome. Yeah, thank you.
Right, it was like only in the last week or two I discovered that. And then I had an aha moment. Oh, that's why on these certain so-called measured values, there's a discrepancy between them and the ether. It's because they manipulated the values.
Yeah, when you said that, I was like, shocker, shocker, what a surprise.
Yeah, back 50 years ago, we always very, very carefully actually measured things, and we never fudged the numbers. If it didn't seem right, we wrote down what we saw, whether it seemed right or not.
Right.
Oh yeah, they had to get rid of you guys. That's going to be a problem later on.
Yep, I'm sure they were very happy to see my generation go. In fact, I was in the generation where they were encouraging us very strongly to go into really hard sciences, part of the space program. And then they realized, oh, we made a horrible mistake here. There's too many smart people. We need to lay off the PhDs so they have to go to jobs at McDonald's, and nobody wants to study anything anymore. And we got to dumb down America somehow.
The classic bait and switch.
The Kansas City Shuffle.
They get us every time.
As I recall, the 9/11 Commission cited a NIST report that supported the collapse of the building because of internal structural failure.
Huh.
And so that's one of the few times that I've even heard of NIST mentioned. But I do remember that it was cited by the 9/11 Commission to support their conclusion that the buildings collapsed due to the fires on the upper floors.
Well, Dr. Mike wasn't there at that time, so that explains it. There you go.
And that's after I was long gone from the Air Force.
Yep.
I was actually on 18th Street walking to work on that morning, and I saw the plane going, the one coming from the north, that hit the north tower. I saw that between the buildings, incredibly low. The building, the plane looked as big as it does when you're at the airport. So in other words, I just saw it quickly go over space between buildings. That's how low it was. And the engines were screaming. When I got to work, everyone was glued to the TV, of course, that that there had been a collision of the airplane with the North Tower. But then I saw films afterwards which showed the actual collapse of the North Tower. And the timing of the frames of the video showed that it took 10 seconds for a 103 floor story building to collapse to the ground, which is free fall velocity. So as a physicist, I knew that only if an object is falling with no resistive force can it achieve free fall acceleration and fall in 10 seconds, the roof of the building reaching the ground in about 10 seconds. So that was my first suspicion that as a physicist, I had questions about whether this was a collapse floor by floor, in which each floor received the impact from the floor above and it so-called pancaked down. Or was this a timed demolition in which each floor blew out in the precise time needed so that it would fall in free fall before the floor on top of it reached it? And that's the only conclusion that I can reach, is that just the observation of free fall velocities indicates that it must have been a demolition. It can't be a collapse floor by floor, because each floor would resist the impact from above. I don't know how we got into that, but
No, that's super important. I'm glad you did.
You brought us there, Dr. Bennett, and I'm super happy about it.
No, that's crazy. I always thought there was no planes, man. I've seen so many weird CGI things that I was a no planer, but you're saying you actually saw and heard it, huh?
I didn't see the collapse. I saw the plane that was going before it hit the tower. I was on 18th Street, which is like 40 blocks north of the Trade Center. when I got back home and I looked at the films, which everyone can see, you can just time the frames of the fall. You can time the fall yourself. You'll get about 10 seconds. And the same thing is true for building number 7, which collapsed later on, even though
That
it
doesn't
wasn't
make
even hit.
sense.
Yeah, it wasn't even hit, but they claim there were fires that spread from the roof down to the basement using a steel scaffold building to collapse. So,
Dude, think about how crazy that is. On the only time in history that's ever happened, it happened to 3 separate buildings on the same day.
what a coincidence.
That's badass.
There's still people that defend that explanation, Cassander. That say, oh, it's just the fire, from the corner of the building got lit up, and that's why building 7 fell. And it's like, what? At free fall speed?
Well, there's
But
still people that believe in special relativity, even though I went over that Einstein train experiment, and
exactly.
nobody, by the way, has answered the challenge. 2 people tried to. One didn't even know what the problem was, wanted it explained, and the other one just took an AI chatbot response. They plugged in the challenge, and they got, of course, the mainstream response that no, Einstein is right, and if you disagree, you're wrong. So, if people believe 2 + 2 = 5, I don't think there's much you can do. It's just a impossible equation. If you encounter someone who says 2 + 2 = 5, then you have to say that's a showstopper. If you believe that, I can't believe anything more that you say until you correct what is an obvious contradiction. So
I love the showstopper.
that's you got to demand that, because otherwise people can say, well, yeah, that's wrong, but here's other things that are right, and all of the other things that I have right are going to cancel out what you pointed out is wrong. The whole idea of logic is that if you find one reason, credible reason, for denying a hypothesis, and it isn't answered, and there's no reason to continue beyond that, will you resolve what the contradiction is?
Exactly.
Everything else is a waste of time. When are the guys coming back from Antarctica?
Not too sure. Soon though.
Yeah, they ended up having to
we,
come back a day early, so they should be already on their way back. I think Witsit's in flight now. What were you saying, Beast?
I was just gonna say, are we done with Dr. Mike's presentation, or any more questions?
Oh yeah, I'm sorry, dude. Dr. Mike, thank you for the excellent presentation, man. That was really good, and I look forward to using the new line of argumentation and putting that forward. It's going to be awesome, man. What a gift. And also a dual Prezi from the boys. You and Cass are teaming up, dude. That's like, dude,
That's gonna be epic.
it's going to be awesome.
It should be interesting.
Cool. All right. Well, if Liliana's here, maybe we'll be blessed with a Brushtail coffee commercial. But if not, I guess we'll fire her on the spot and hire somebody else.
Need to be careful how you treat the ambassador.
Hey, she
Cool,
signed the
cool, cool.
contract.
Ah, wow, this mic took longer than usual. Oh, can you guys hear me at all?
Yes,
I'm calling
ambassadors.
you. Yes, I'm calling you from very, very far away. I got abducted by some aliens. Please don't worry. These aliens, these ETs happen to be good ones, and they are after coffee, and they have gone crazy for brushtail coffee. They drink tiny sips of it, only a thimbleful of it, because they're tiny ETs. They're the grays, they're very tiny. And all they want is brushtail coffee. And when they drink this brushtail coffee, they laugh as if they're like these jolly drunks. It's really funny and they crack jokes and it's hilarious. So, yes, please don't worry, I'm safe. It's just that I am asking you guys to be warned that there might be a shortage of brushtail coffee because these aliens, the ETs, have discovered it and they're buying it up for gold, folks. So get your share of brushtail coffee while you can, and I will try to get back as soon as possible. These ETs are very nice. I told them I want to go back home to Earth, so they will bring me back. But they think I make this stuff in my kitchen. That's why they took me. And I keep telling them, no, it's brushtail coffee. But they just laugh and they just think that I make it in my kitchen. Anyways, buy up brushtail coffee, folks.
Toby's been on the run from these aliens. He's been hiding from them. They've been trying to get to his brushtail coffee. There's a whole thing involved.
So we have a reason for the sabbatical.
He's on the run until the alien invasion can be settled.
The brushtail coffee must flow.
Exactly. The only thing that's preventing them from taking over right now is the fact that they wouldn't know where to get brushtail coffee at. They can't find Toby's supplier. As long as we keep Toby hidden from the aliens, we'll be fine. All right, so tune in for Thursday, Research and Reading Night. And then Friday will be Flat Earth Fridays, episode 123, where we're going to be talking about Antarctica, I assume. Right? So join us for that. And then next week will be a presentation on optics, probably.